Hello everyone, myself Shiva Prasad. I'm currently studying BCA in ICCA College Davangere. So today in this video I will be demonstrating you a Python script or Python program which is going to convert raw files or images to a normal or JPG or PNG format. So let's get straight to the point. So as you can see on screen, we are including, importing or using multiple libraries from the Python. So the first library is OS. We are using the OS library because here we are working with directories and files, and we are using the rawpy library from the Python because we are using raw files to be processed here. And the third one is image.io, which is used to save and work on an image. And the fourth and last one is multiprocessing, because here we are using multiprocessing because we are processing multiple raw files which are like 1000 to 2000 files. So we need multiprocessing. If we use the serial processing, it takes a lot of time and less hardware, which is less efficient. And in next two lines here we can see the input directory and output directory. We have declared the input and output directory once, and this variable is used everywhere. And the next line, as we can see here, here we are checking if the output directory is already existing or not. If the output directory is not existing, here it will create using the os.make directory or make dirs. And after that, here we have created a function named raw process or process raw. Here definition is, or df is known as method. You can also call it as method or function. Here it is taking a parameter of input file, like it is the input directory named as input file here. And what this line is doing is it is taking the base name from the input file and stripping out the .raw file and adding the jpeg or png format, or appending the png format, not format but extension. So if you want it as a png, here you can change the extension to the png. And after that, here it is processing the file using the rawpy and saving the file using the image.io or image.io. So here we are using rawpy and reading the input file, which is the raw, and we are creating the raw file and post processing it and saving it to the RGB format. Like in a raw file, there are multiple types of attributes or multiple types of specified things are stored, like aperture, brightness, contrast, etc, etc. And we are using the image.io library and saving it to the output file. Format is used to save it as a jpg, png, or other type of file. After this is all purely multiprocessing things or multi-threading things. Here we are checking the condition. If the name is equal to main, that means if this script is running individually, or if it is running as a module. If it is running as an individually, it will use the multiprocessing. And if it is if this script is imported as a module to the another Python script, then it will run as a serial processing, because it may occur like what you can say is it may give some errors, or it may work wrongly and may damage to the hardware. So we are just taking an decision here. Here we are using this block of code to check the number of files existing in an folder with the extension of cr3. It will make a list of those files, and it will distribute all those number of files equally, or using another type of algorithm, it will distribute all the file to the cores inside your processor. And we are accessing the number of process count, or number of logical process count from your processor or CPU using this block of code. Here we are with using multiprocessing library. We are creating a pool of processors, and the map is used to allocate the number of resources or number of files to the each core. And once every file is what processed or executed, and every files are empty in the like what input directory, it will print this statement known as processing is complete. Compressed images are saved in this directory, where the output directory is embedded here. So it is all about the code here. Let me show you the actual execution. So here we have a bunch of photos, which is like 15 items, and total it has 321 MB of space. So you may ask why we need all this much of code and all this of much parallel processing for just for our 10 to 15 photos. We can do it with Photoshop also. Yes, you can do that in a Photoshop, but when it comes to the actual size of data, I am here currently having 21 GB of photos with nearly what 1097 files. So if you can, like, obviously you can do 1097 files in Photoshop, but it takes a massive amount of time, effort, and energy. And let us take a consideration that I have like what 10 to 15 like videos in that file also, then still we remain with the 1000 photos. So here it is like what 15 items of 323 MB, and here is the output file known as converted. And here also I have given the same what directories or path. And let me open the task manager for you, just to show you how much like that resources is utilizing. Always on, let's take this as always on top. I don't want this. As you can see, I have GPU, CPU, memory, disk, and network all accessed. So let's go here and see, and like okay, wait a minute. So you may like if you are doing this program directly in the Python, it may show you some like what yellow color squiggly lines under these. So let me show you. See the like, command prompt, and let's uninstall the raw thing. Okay, pip uninstall, install. What is that? Let's take raw py. Paste it, and it found the installation path, and now it is uninstalling. Let me tell y, which is s, and it successfully uninstalled it. So let me go to the raw py and let's save this. Yeah, as you can see, it is showing this yellow color squiggly line, which means the you have imported the library, but the actual library is not in your local machine. So if you need to install any type of like libraries from the online, you just need to do is pip install the raw py, and once it found the uh, like what library in the internet, it will collect and it will install to the you install to your local machine and add that path to the path library in your global environment. So you don't need to worry about the path. So once it is done, let's go to the okay, let us execute here only. We can also do cmd, and we can paste the path of the actual python file and the python file name, and it will directly execute. So let me run it from the Visual Studio Code itself. So as you can see that python 3.11 was running here, and as you can see it is utilizing all 100% of our CPU, which means the parallel processing is working. Let's go to the crv3, and here is the converted images. So if we select every file from the converted image, it is like 70 MB, and in the cr3 if we select all, it is like what 321 MB, which means it is like compressing at a good level, which means it is keeping the quality and size in a mediocre manner. So as you can see, let me open one file and let me zoom here. As you can see, it is like a raw file. Let me tell you before itself. It is the raw file and it has the good quality here, obviously. And let us go to the converted file. It has made some like what color grading by itself, also itself, and it has chosen the best amount or the best what it can do by the algorithm itself. So as you can see, like it looks natural compared to the raw file. And if we like zoom very deeply, it is not the very good or very highest quality compared to the raw, but it is somewhat okay and somewhat good. So I believe I have done my side of thing. I have tried my best to do or tell everything as much as I can. So okay, that's it for today's video. Let me meet you in the next video. Bye.